Welcome to Study Loop.
Okay, so here we're given this probability density function, which is 4 pi of m over 2 pi kt 3 halves times v squared e to the negative mv squared over 2kt. Okay, so we need to find the mean. Now, if you recall, the mean is, in this case, v PV. So that is, you take the independent variable of some probability function, and then you multiply it by that probability function and integrate. So that's how we find the mean. So I'm going to get, well, I'll take out my constants first. I'll get 4 pi m over 2 pi kt to the 3 halves. The integral from 0 to infinity, by the way, of v squared, v cubed, I'm sorry, because I need to multiply that v by this whole side of the equation, e to the negative mv squared over 2kt dv. So the big issue here is that this is just a really dense integral. There's just a lot going on. So what would make things way easier is if we could write these complex pieces in terms of something much simpler, right? Which is really what u substitution is. So I'm going to have u equals negative mv squared over 2kt. And I'm mainly choosing it because it's the ugliest piece, okay? So that'll really make things easier. So now du is negative mv over over kt dv, right? So what I would need to do is I want to think of, just by thinking ahead a little bit, I want to think of v cubed as, instead, I want to see it as v squared times v. So I'm actually going to break these up. V dv, and you'll see why I'm doing that in just a second. So I need to replace dv. So what I want to do is I want to solve for dv, but if you look here, I have v dv and I have v dv right here, right? So I can just solve my du equation for v dv, and so that's why I broke them up, right? So I will get v dv equals negative kt over m. Oh, I'm sorry, negative kt du over m. And then v squared, I need to solve my u equation for v squared, and I will get v squared equals negative 2k tu over m. So now I can rewrite this integral as negative 2k tu over m times e to the u du. So that just became far simpler, and these are all constants. So I'm going to get rid of them. I'm going to put them on the outside of the integral along with this, and then I'm going to have to simplify all that. So 4 pi m over 2 pi kt to the 3 halves times, let me make some room here. Put that u back. Times, let's see here, negative 2kt over m times negative kt over m, which is really messy. So I'm just going to simplify these constants on the outside first. When you boil all that down, you're going to get 8tk over pi m to the 1/2. Okay, so now I'm going to go back to this integral where I'll have u e to the u du, right? This is great integration by part stuff, and I'm going to use the tabular method. I think it'll make this very, very simple. So I want my differentiation side to start to go to 0, right? So e, the derivative I'm sorry, u, the derivative of u is 1. The derivative of 1 with respect to u is 0. And I'm going to integrate my e to the u. E to the u is e to the u is e to the u. Pretty simple. And then I'm going to multiply diagonally. So now I'm going to have 8 tk over pi m to the 1/2. And I will have u e to the u plus e to the u from infinity to 0. So this is an improper integral. So I'm going to need to set up a limit and take the limit of some arbitrarily named variable as it approaches infinity. But we have to keep track of what's going on here. What's going on is I need to see what happens to the probability as this velocity approaches 0, not u. So I need to rewrite this in terms, the original terms, in terms of velocity. But first, I'm going to factor out an EU, so things will just kind of become a little bit simpler as we go. So now, I remember that U was negative mv squared over 2kt. So that means that I have 8tk over pi m to the 1/2. I'm sorry, I want a limit actually. The limit, I'm going to use b as b approaches infinity, and I'm just going to write all this in terms of v. So I have e to the negative mv squared over 2kt, negative mv squared over 2kt plus 1 minus e to the, well, I'm just plugging in 0, right? So I can already tell you that's going to be 0, e to the 0, and then 0 plus 1, right? Oh, I'm sorry, no, 0 minus 1, because I have negative mv squared. 0 minus 1, right? So if I take the limit as, oh, my mistake. This should be, both of these should be b's, because remember I made it b. Okay. So what's going to happen is this, anytime you have e or any number to a negative exponent, and the negative exponent goes to infinity, this whole thing actually just goes to 0, right? So if this goes to 0, then this goes away completely because it's multiplying by 0. So I'm left with negative 1, which is 1, times my constant. So I have 1 times 8tk over pi m to the 1/2. And so that is why the average value is 8tk over pi m to the 1/2 power.